Here's some tricks for dealing with the vostok questions on homework 2. So the way my spreadsheet is set up, this is the concentration. Here are the years. This is the age of the entrapped ice. Now, if I'd like to find the difference, the average difference in years, this can be really tedious if I do this out. There are 363 numbers here. So the reason people use spreadsheets is because you can enter formulas. So you start with an equal sign, and then I can click on a cell, and then an operation like a minus sign, and then another cell, C2 minus C1. And it does the subtraction for me. Now that's nice. Here's the really nice part. If I click on that cell, there's a little box here, and I can drag that cell. I click on the box and drag. And what happens? What are these numbers? Well, if I click on any one of those cells, you can see it's updated. It's automatically updated the formula to some other pair of cells. So I don't have to retype in C8 minus C7. It just does it for me. So these are the differences between all the different data points. Some data points are 1,000 years apart, 200, 2,000, 100, 700. So I can drag this all the way down my spreadsheet. A bit more to go here. 200,000, 300,000. There we go. Then I have all of them. And now, just like before, you can calculate the average of that list of numbers, right? So you know how to do that. Now another thing you can do. So I ask you to do a difference between high and low values. Right? So find out the rate of change. Well, you can just scan along here. Look what's happening. They're going down, down. And in fact, it doesn't hurt to have a graph of the vostok ice core up and available, which I just thought of. Ice core graph, which should specify CO2. Where are we? There we go. So this is essentially the graph you had. Now when you're going to win those numbers, you should be able to tell where you are. You start high, you go low. So if we go back to our data, right? I start at 284 here. This is actually the most recent. And then as I go down here, this 182, this is a local minimum, be down there. And if you want to do a different one, go back up again. And then notice that it's a bit hippy-dippy until you get to the bottom. So go back up. There's 209. Up and down, up and down. Where are we? We can look for what's the highest. You know, look, maybe either here or there. So you can also estimate looking at the graph. Oh, I know what it is. We're reading ours backwards. So we're over here. So it's up and down for a while. So somewhere after 100,000 years, there's a max. So you can right here. So we're close. So somewhere 45, 65. So just trying to find a big gap. You know, there's something. 120,000 years back, we're at 286. And then how low does it get? Down to the 190s. Any of these are fine. But these will give you 2 points that you can compare. So try to find something really steep like this, or really steep like this. What's the steepest part of this graph? See if you can find that. All right. If you want to do something particularly fancy, you could do something like this. You don't have to do this, but you could you could do equals, parenthesis, something like this over a change in years. Now I might have my signs wrong here, but this will give you a notion of slope. And you could go ahead and find, these are always slopes over pairs of points. So it's a little limiting. But if you enjoy spreadsheets and playing around, you might be able to improve upon this. So then you could go ahead, you have all the slopes between consecutive pairs of numbers. What was the zero there? That's weird. And then you can do things like there's a max function. It will give you the max value. There's a min function and the min value. So you can actually find the maximum rate of change in the vostok ice data or the minimum rate of change. And we can do the average rate of change over all of them. If you do that, though, that is, if you like doing this kind of stuff, if you do an average, you should be careful, since if you do an average rate of change, you have to be a little careful. I don't know why they didn't copy it out. Oh, I know why. That you use an absolute value here, because otherwise you'll get cancellations. So you might do ABS as absolute value. And then you can just find the rate of change of all these without worrying about positive and negative. It seems to increase and decrease. There are steep increases. They're not steep, actually, as you'll find out. There are apparently steep increases and apparently steep decreases. So now the numbers are all positive. And now you can look for an average of these numbers. You can look for a max of these numbers, a min of these numbers. So there's a lot of tricks you can do here. But the idea is to get a sense for how do these rates compare to the Mauna Loa.